Graphs are an important part of math. They provide visual representation of mathematical changes and concepts. We can observe certain dynamics by looking at a graph, and at times we can even solve certain problems. Anyway, let's start with the basics. A graph has a standard look and feel. It has an x-axis that goes from left to right and a y-axis that goes from south to north. So the x-axis being horizontal, at some point intersects the y-axis that is vertical. And that point of intersection is called the origin. The origin has coordinates of 0, 0. And then both x and y-axis from that point to the left, the x-axis has negative values, and to the right, it goes into positive direction. And similarly, y directed upward to the north from the origin of 0, 0, you have positive numbers, and going below the point of intersection, they go negative direction. Let's put a line on the graph. And this line is represented by the equation of y equals x plus 3. We will get to find how come this equation is the one that represents the line. In the meantime, let's take a look at the standard look of a linear equation. A linear equation is an equation that represents a line. And it has a look of y equals impact times x plus starting point. In this case, I'm not using much of a mathematical terminology, just to keep things simple. So once we understand the concept, then we can, of course, learn the terminology. This formula indicates the relationship of dots on the given line. And y and x are connected to the x-axis and y-axis, and we will see how that is. Before we explain the parts in the bracket, the impact, and the starting point, let's first review slope. Slope is an important part of a line. It indicates at which angle this line proceeds and whether it goes up or down or straight or otherwise. And the slope is defined quite narrowly. It is as a formula of change in y relative to change in x. And to find the slope, we need to define this change on the y coordinate to the change in the x coordinate. So before we could do so, let's first take a look at a certain point that would demonstrate us how to go about this. Look at this blue dot. It is located at some point on the coordinate plane, and it has coordinates that describe its location. The way we provide this location is by listing the x coordinate and the y coordinate of this point. And the x coordinate defines how far from the origin on the x-axis this dot is, and then where it is located relative to the origin on the y-axis. Let's attempt to define its location. Let's draw a line to the x-axis, and we can see that we hit the axis at number 5. And let's do the same by applying the line to the y-axis. And our location is 5 and minus 5. It is important to note that the x coordinate is always listed first, and then we list the y coordinate. So the location of this blue dot is 5, minus 5 in the brackets. Let's shift back to our line. We're trying to find slope, and slope is defined as change in the y coordinate divided by the change in the x coordinate. So let's pick two spots on the line, and the easiest candidates are the points of intersection with the y-axis and the x-axis. Our line crosses y-axis at the point with the coordinates of x equals 0, y equals 3. And the second point crosses the x-axis at the point of the x-coordinate is -3 and the y-coordinate is 0. Please check for yourself that you agree with these coordinates for these 2 points. It doesn't matter which 2 points we choose, so we pick the ones that are the easiest to define on our coordinate plane. So now that we're trying to measure the change in y, we need to go from left to right. So we first look at the y-coordinate of the point that is to the left, and its dimension is 0, since the second number of the coordinate is the y-coordinate. And then let's take a look at the point that is on the y-axis, and its y-coordinate equals to 3. So we can say that the y-coordinate changed from 0, the point to the left, to 3, the point to the right. Using the same approach, let's evaluate our x-coordinates from the point to the left to the point to the right. The point to the left has the x-coordinate at -3, and the point to the right has the x-coordinate of 0. So we can say that change in the x-coordinate is from -3 to 0. So let's move on. What does it mean, 0 to +3? Well, 0 to +3 means that our y-coordinate changed by 3 in the positive direction, so that's a +3. And the same happened in the x-coordinate. We went from -3 to 0, which means we grew by 3. And that sets up our 3 divided by 3 fraction. And we know that 3 divided by 3 equals 1. So we can say that the slope of this line equals to 1. To cement our understanding of how to understand a line on a graph, let's take a look at another one. In this case, we will find the formula that describes this line, or the equation that describes this line, ourselves. In order to do so, let's pick 2 points, just like in the previous example. And the first point will be the one that I just pointed here. Let's look at its dimensions. If we go to the left, we can see that it crosses the y-axis at -1. And if we go up, we see that it crosses the x-axis at 7. Since the way we write location, or the coordinates of every dot, is that we first list the x-coordinate and then the y-coordinate, we will write it accordingly. So the coordinates of this point are 7 for x and -1 for y. And the second point that we'll pick will be the origins, since we can see that this line crosses the point of origin. And as we know, the coordinates there are 0 and 0. Let's now define the slope for this line. As we know, slope equals change in the coordinate y divided by the change in the coordinate x. It is very important to note that it is y over x, not change in x over y. So this is one of those things where you just have to remember it. And if we look at our coordinates for the 2 points that we defined, from left to right, the point to the left is the point of origin, 0, 0, which means that the coordinate y equals to 0. And the point to the right, the one with the coordinates of 7, -1, has -1 as the dimension for coordinate y. So we can write it down that our y changed from 0 to -1. Accordingly, we also go from left to right. Our x dimension of the coordinate went from 0 to 7. So as we proceed in the numerator, 0 to -1 means a decrease of 1, and decrease means minus. So we went in the -1 direction. And from 0 to +7, we grew by 7, so that's a positive growth. So we write down 7. As a result, we get a fraction of minus 1 over 7. And this is our slope. Let's get back to our simplified definition of the linear equation. Y equals impact times x plus starting point. So in this formula, impact is the slope. And we just found the slope. As we know, slope describes the angle at which the line either grows or goes down or maybe stays flat. And the starting point is the point of y-intercept. Y-intercept is a coordinate of y at the point of crossing the y-axis. For green line, that would be 3, because it crosses at the point of 0 and 3, and the y dimension is 3. And for the other line, it crosses at 0, 0, which means the y dimension is 0. So let's define the equation for the green line. The equation for green line would be y equals, our impact or slope is 1 times x plus starting point or y-intercept is 3. So here we get this formula y equals x plus 3, the one that we defined on the line itself when we just put down this line. By the same method, our pink line has the equation of y equals minus 1 over 7, which is a slope, times x, plus starting point or y-intercept of 0. And let's put it down as in simplified format. Y equals minus 1 over 7 times x. So what is this equation? Well, this equation defines all the points that belong to the line. And we can actually put a line together based on an equation. Let's say we're given an equation, y equals 2x minus 1. Looking at it, we can already identify that 2 must represent slope and minus 1 must represent y-intercept. To draw any line, we only need 2 points. Let's apply the formula that we're provided, y equals 2x minus 1, to define 2 points. So point number 1, let's just pick x equals 0 for starters and apply the formula y equals 2x minus 1. If x equals 0, y equals 2 times 0 minus 1, it equals minus 1. So one of the 2 points is at the location of x 0, minus 1 is the y coordinate, 0 and minus 1. And the second point would be, let's take number 2, x equals 2, and then plug in the formula, y equals 2 times x, which is 2, minus 1, and that equals 3. So the second point would be x coordinate 2, y coordinate 3. So the location is at 2 and 3. Now let's plot the 2 dots and connect them into a line.